Okay, question 2a. Figure 1 below shows the line spectrum of hydrogen atom in the visible region. So the key word for this question is visible region, because we know that if it's a visible region, it is the Balmer series with the NF value of 2. So the final value is equals to 2. Now the question, calculate the wavelength in nanometer of photon emitted to produce line B. So we are going to use this formula, and when we use this formula we need to remember that the N1 value must be always smaller than the N2 value. That is one of the tips. Okay, so after the calculation, this is the working, and you will get the final value of 4.86 times 10 to the power of 2 nanometer. Now for this question, calculate the energy of an electron at its excited state before it drops to produce line A. So the key word for this question is energy, electron, excited state, before drops, produce line A. So for this question, we are going to use the formula. Okay, we are going to use this formula, and after substituting, we are going to get the answer of negative 1.363 times 10 to the power of negative 19 joule. So the difference between the question before this and this question is the Ribot constant. So the Ribot constant used for this question and the previous question is different. So that is one of the key things that we need to identify. The electronic configuration of an atom C is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1. First question is, write a possible set of quantum number for the 10th electron. Now the key word in this question is write possible set quantum numbers 10th electron. So now we know that the 10th electron is located at the 2p orbital, and this is the orbital diagram for the 2p orbital. To write the quantum number, we need to know how do you write it first. What are the orders? So this is the order that we follow to write the quantum number, which is principal quantum number first, and then the angular momentum quantum number, then the magnetic quantum number, then lastly the electron spin quantum number. Now the principal quantum number, it corresponds to the energy level of the electron. Since like the 10th electron is located at the 2p orbital, thus n is equals to 2. Now when an electron is in the p orbital, that means its L is always equals to 1, because the angular momentum quantum number, it refers to the shape of the orbital. And then since the L is equals to 1, that means your M, which is the magnetic quantum number, you have three options, which is negative 1, 0, or positive 1. But now, since it is the 10th electron, that means the M is equals to positive 1. Now, for S, the electron spin is towards down for the 10th electron. So it is negative 1 over 2. Now the second question is, draw the shape of orbitals for the valence electron. So the keyword here is draw shape of orbital valence electron. So this is the shape for the valence electron. This is the 4s shape, and that is the 3d shape. So for 4s, it is better for us to draw a bigger circle because it is in the 4s orbital, whereas for 3d you have 5 options. So in that 5 option, I have chose 3dxy. So this is the shape, and you have to remember when it is in the d orbital, it is a clover shape. Now for question Roman 3, determine the rule used to arrange the 6th and 7th electron in the 2p orbital. So the keyword for the question is the one that I have highlighted, which is determine. So state, then based on the 3 rules, the rule that is the most acceptable for this question, the correct answer is Hund's rule. Actual electronic configuration of copper. Explain why the expected electronic configuration of copper is different from the actual electronic configuration. So the tips for this kind of question is that you have to highlight the keyword. And so now the keyword for these keywords for this question are actual, explain why there is difference in the actual and also actual. Okay, so this is the explanation. The expected electronic configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d9, which is arranged based on the Aufbau principle. So based on the Aufbau principle, this is how you will arrange. So this is what it is expected. However, the actual electronic configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d 4. This is because copper is an anomalous case. So we know that copper and chromium are both anomalous case. So in its anomalous filling pattern, it is due to its extra stability of completely filled 3d10 subshell. Thus, there is a difference between the expected and actual electronic configuration